Find the Z transformation of 2n plus 3 by n plus 1 into n plus 2. Right? Same like previous problem. So here in numerator you are having 2n plus 3. But denominator same as previous problem. n1 by n plus 1 into n plus 2. Take f of n which is equal to 2n plus 3 by n plus 1 into n plus 2. Now again we are going to split the fraction 2n plus 3 by n plus 1 into n plus 2 by using partial fraction. So let it be a by n plus 1 plus b by n plus 2. That is equation number 1. Multiply both sides by n plus 1 into n plus 2. So you will get 2n plus 3 in the left hand side, which is equal to a into n plus 2 plus n plus 1. Put n is equal to minus 1. So in the left hand side 2 into minus 1 minus 2 plus 3, right? In the right hand side a into minus 1 plus 2 plus b into minus 1 plus 1. So you will get a equal to 1. Put n is equal to minus 2. So minus 4 plus 3 in the left hand side, which is equal to a into minus 2 plus 2 plus b into minus 2 plus 1. So b equal to 1, right? Because minus b which is equal to minus 1. So b equal to 1. Using a and b values in 1. So 2n plus 3 by n plus 1 into n plus 2 becomes 1 by n plus 1 plus 1 by n plus 2. So z, taking z transformation, so on both sides. So and separate the z transformation on the right hand side. So z of 1 by n plus 1 plus z of 1 by n plus 2. That is the equation number 2. We know z of 1 by n plus 1 which is equal to z log z by z minus 1. That is equation number 3. Again we need to find the value of z of 1 by n plus 2. So we take the formula z transformation formula z of f of n which is equal to summation n is equal to 0 to infinite f of n z power minus n. Here instead of f of n you are having 1 by n plus 2. So we will get summation n is equal to 0 to infinite 1 by n plus 2 z power minus n, which is equal to 1 by n plus 2 into 1 by z power n, because z power minus n can be written as 1 by z power n. So 1 by z power n can be written as 1 by z the whole power n, right? So take 1 by z the whole power n to the numerator. So summation n is equal to 0 to infinite 1 by z power n by n plus 2. So expanding n is equal to 0. So you will get 1 by 2. When n is equal to 1, you will get 1 by z by 3. 1 plus 2, right? 3 plus etc. etc. So multiply numerator and denominator on the right hand side by 1 by z the whole square, right? So you will get 1 by z square outside, 1 by z whole square outside, multiply 1 by z whole square inside in the numerator, right? So you will get 1 by z square by 2 plus 1 by z cube by 3 plus 1 by z power 4 by 4, adding 1 by z by 1 and subtracting 1 by z by 1 for the adjustment. So adding and subtracting 1 by z by 1. So you will get the expression, because we know the formula log 1 minus x minus log 1 minus x is equal to x plus x square by 2 plus x cube by 3, etc. etc. So we are going to use that formula. That is why we made adjustment like this, right? So it is equal to 1 by z square. So it can be written as minus log 1 minus x. Instead of x you are having 1 by z. So 1 minus log 1 minus 1 by z. Then the remaining term minus 1 by z. So this is equal to z square, because 1 by z square becomes z square, right? Minus log, taking LCM, z minus 1 by z, right? Minus 1 by z. So z square log, this can be written as z by z minus 1, because minus 1 log z minus 1 by z can be written as log z minus 1 by z power minus 1. Z minus 1 by z power minus 1 is nothing but its reciprocal z by z minus 1. So this becomes z square into log z by z minus 1 minus 1 by z. Therefore z of 1 by n plus 2 which is equal to z square log z by z minus 1 multiplying z square inside. So z square by z, you will get z minus z. That is equation number 4. So substituting 3, 4 in 2. So z transformation of 2n plus 3 by n plus 1 into n plus 2, which is equal to z log z by z minus 1 plus z square log z by z minus 1 minus z. So in the first two terms, so you are having log z by z minus 1 common. Take it outside. So first term z, second term plus z square. So z plus z square into log z by z minus 1 minus z. Thanks.